Okay, let's get started. Hello, everyone. I'm Neil. I'm the lecturer for the second part of this course. I know the first half is a little bit theoretical, so the second part will be very different. It's very practical. So I'm Neil. I think I already introduced myself during the capstone project. Just to briefly introduce you again. So has been in Singapore for 18 years, originally from China. Done my own startup before, like in the first two part of my own startups, doing it in Singapore. The third one, I joined a company called Twilio as the third employee for Twilio in APAC. And the fourth one is a little bit relevant to this course. I joined a company called PingCAP. So we're doing this distributed database as the, I think, world number one or number two distributed database nowadays still. The database is called TiDB. So then I found my own company called Reddio, where we scale Ethereum for the past 2 years. So another side of myself, this is my education background. So for this course, I also teach in the year 4 students in NTU on the blockchain together with Prof. Lee. So during this course, I also brought some of the material from that class. So that one is year 4 students where we talk a lot about the fundamentals, but you guys already learned a lot during the past few months. I won't touch too much on that piece so that you won't hear too many information repeat. But I'll still highlight some of the information is important for you to dive deeper for this second half of the class. So these are the outlining of this lecture. So literally when I started to teach this course about a year ago, this is my second year teaching this course, which is actually literally the second batch, right? There's no material for what I'm going to teach. So basically I have to went back and study and then abstract those concepts and trying to bring those concepts to the lecture room to discuss with the students and also get some ideas back and also discuss with some industry players and see whether those whole concepts make sense or not. But definitely the industry has been there for a long time. The reason it's very dynamic is really because the industry has been really evolving very fast. So there's a reason behind that. Maybe throughout the lecture you will know why. But anyway, this is outlining where today will be very light today, just introduction to scalability. What are the problems? What are the scalability is trying to resolve from the issue perspective? And also we talk about the core essence for the blockchain scalability, which is the blockchain-Trilemma. And then, so for the following few lectures, we'll talk about from industry perspective, how the industry has been scaling blockchain from like layer 1, on-chain scalability, or bring the scalability to off-chain on layer 2. What does those terms mean to the scalability? And we focus a lot on optimistic rollup and ZK rollup for the layer 2 scaling because at least last year, that was very popular. This year, there are a lot of changes. That's why I'm adding a little bit new element this year, which is EVM scaling, where we'll talk about how to scale the virtual machine on Ethereum. I'll touch on that topic a little bit because this topic was not there actually last year, and I added for this year for you guys. Then we talk about storage scalability, computation scalability, and consensus scalability at the end of the course. If we got time, I may walk you through how, if you are an engineer working on a blockchain company, how you can build a blockchain. What are the tools available, how you can build that for different purpose. Then the last but not least are the exams. As you already know, this course we take a quiz, not the final exam. Yep. So these are the two reference books mainly. So this tool has been really the Bible for blockchain. Has been really well written, thought of, and now they went on to third edition for mastering blockchain already, and second edition for master Ethereum. The third reference book is actually new this year. So because I decided to write this book, because there's no reference book at all for if you talk about blockchain scalability. So you guys can scan the QR code and find the link there. I also are basically using a very new way to write a new book. It's a fully open source book. And I was trying to convince people come over to contribute to the source code. That's where the developer can just pull a PR and submit their new changes and proposals if there are any. So hopefully by end of this semester, I can get this book done. But so far, I only write till the layer 1 on-chain scalability. So it is still in progress. I welcome you guys start the book because more people will be able to know. And also, if you find any errors when reading the book, if you are interested, feel free to submit a PR. I'm more than welcome. Maybe there are extra bonus for that. Because this book will be the reference book, if not this year, will be for next year. Okay, the first, which is for this lecture, is the scalability issues in blockchain. And we dive into the problems and the challenges. I always use this chart to compare from now, where the Ethereum stand compared to the most mature Web2 payment network Visa, where the gap, right? This gap means a lot of opportunities even for you guys because the industry has been really evolving. But on the other hand, if you want to scale the blockchain, before the technology really mature, if you are doing a project, what can you do? What can you choose from the current solutions we're going to describe? So another thing I want to highlight is I will still go through some of the things already, what we deem as a technology already in the past. But the reason we repeat those is the technology is always a spiral cycle. So any old technologies can be adapted to the new technologies. You will see the narratives for the blockchain scaling has been changing, but also adding the old elements into the new scaling solutions. That's why understand the technology in the past is super important. No matter you are doing projects or understanding a scaling solution, a new scaling solution, why it does that. So as you all know, the Ethereum scaling so far is 20 transactions per second. How can you scale when you're doing applications, right? It's just tremendous work still. So on the other hand, when we zoom into the Ethereum, there's a big issue for the gas cost. Why? Because any transaction you are doing on the Ethereum, so they have a wallet to calculate the estimate gas cost for different type of transactions. Take the transfer, for example, it costs about 21,000 GUI as a gas cost for that transfer. Which means when you transcode that GUI into the price, this is the price for that transfer. But that's only a basic gas cost. So if you understand the Ethereum, everything will come to a mempool first. They queue up, all the transactions queue up in a mempool. And the miners will take about each block they can take maximum this amount of gas to generate the block, right? So if we take a transfer, for example, if we want to transfer the money in the next minute, the next block can only generate this amount of transactions, which is about 600 transactions in that block. So the miners are not stupid. They always choose the one who give the best guess to pick and generate the next block, right? So that's where whoever pays the gas the most win that next block. That's how Ethereum design on the tokenomics piece and also the mining piece. That become an incentive for miners to mine the blocks, but also become an issue when the industry facing congested time. What does that mean? So this is a very typical project in the past, I think in 2014 sometime, CryptoKitty, right? This is, for me, it's the first popular NFT projects ever. And this is a typical architecture for CryptoKitty project. So so basically on top you have a front end, on the back you are running on Ethereum for most of the logics, right? So when this project launched, it becomes so popular, you still remember the gas cost logic, right? So when the CryptoKitty project launched, somewhere here, maybe, I think it's somewhere here. Everyone is trying to buy that CryptoKitty and trying to breed the CryptoKitty, which all cost the Ethereum token. That basically make the network super congested, and it's so expensive. Like during this time, I think if you turn the gas to US dollars, it's about $50 US per transaction, right? So moving further, you have this. Any of you know why there's a hike during that time, during 2017? Any of you? No one knows the history. It's the ICO boom, right? Everyone is doing their own ICO, announce their token, and a lot of people are trying to buy the shitty coin or alter coin, whatever you call it. So this is another hype, which is the NFT. The NFT, I still remember when I started my career in Web3, I bought an NFT. It cost me about $100 US to just buy an NFT. So that's some of the current issues for industry, no matter it's the scalability compared to with a master network, and also the gas cost for a lot of blockchains. But when we talk about scalability, we need to define, right? So because there are so many things you can talk about. So what is the scalability? Does it mean it's a higher throughput, the transaction per second part? And does it mean like it's shorter confirmation for the finality, especially the latency part? Or does it mean like I'm going to validate more transactions with the same hardware? Because there are blockchains, they basically use more expensive hardware to accelerate everything, and you thought it's very fast, but actually the sacrifice is the decentralization, right? So when we talk about this, we have to really define clearly so that we know why the technology is scaled in that way, and what does it mean for scalability. And also there's another, people are trying to figure out is like, does it mean like it's non-degrading performance with more transactions, right? So basically there are many different definitions. We were trying to find a real definition from the industry. You guys can take a minute to read this paper. I won't read about it. Yeah, so what does this mean is like, this is actually a professor from WISC. So he is really trying to find the definition, but he can't because there's no de facto definition for scalability even nowadays. People have a different thing when they promote their scaling solutions. But we still have to define, right? I tried few things. So maybe the first attempt, let's try, is like scalability equals to throughput. So that if we think a blockchain is a service, and basically the transactions are the computation task of different difficult tasks, right? So basically, the way to increase that throughput is scalability, right? It's a pure throughput. A lot of people are doing benchmark for different blockchains. They use benchmark testing to test the transaction per second. Basically, how they do that is you generate multiple accounts and trying to transfer, for example, from one account to another account, and you create 1,000 accounts and see how long it finish for the transactions. After that, you have data for the throughput. So if the scalability equals to throughput, so all we need to do is to boost the scalabilities. And the definition of the throughput is always easy. It's the transaction per block divided by block intervals, right? So what does that mean? So if we want to solve this scalability issue and scale, right? So that's all we talk about. So one way to really boost the transaction per block is to increase the hardware performance, adding more hardwares, and the issue for this is like only the powerful server can farm. Like take the Ethereum for example. Everyone want to win the ones to generate the next block. There's a company using ASIC to trying to boost the performance for the mining. But on the other hand, definitely boost the performance for the Ethereum network. Ethereum network used to be only 10 transactions per second when it was born. After the miners has been evolved, now you see the number is about 20 transactions per second, right? You can also use a very application-specific circuit, like IPG or ASIC, to accelerate some of the different blockchains when they are using different mechanisms to generate for the consensus to generate the block. Yeah. So again, the issue is very little decentralizations because all the resources will be gathered together to the farmers who has the most powerful machines. The shorter block time is easy to understand because, for example, nowadays I think Ethereum take about 10 minutes to generate each block, if I remember correctly. Then you basically can reduce the block generation time, right? But there's an issue, right? When you do that, it means it will take, you basically can only take less node for the consensus to agree on this next block. And that means hackers or the farmers can take the advantage to generate forks to different blockchains. And the block information will be not stable at all. And because of that, it's a huge security threat to the blockchain. So the conclusion for this definition is like the scalability should take other measures like decentralization and security into the account. If you don't take this account, why you are using blockchain, why we are doing a blockchain, right? That's the factors we definitely need to consider, right? So I did another second attempt for the scalability. So this is the definition from the Wikipedia. You can read about it quickly. So basically what Wikipedia is trying to say is like it's a vertical scaling. Means you just add more resources like CPU, more memories. You can even use GPUs to accelerate on a single node to achieve the scalability, right? So when you do that, it's, again, a centralization issue. So when you do horizontal scaling, that's another way to scale, to adding more resources. But when you're adding more resources, it will take longer to get a consensus to generate next block, right? So if you want to achieve the consensus in a shorter period of time, maybe only the supercomputers can achieve that. So and also there's a, when you do more nodes, there's a higher latencies between the node to get the consensus. Not mentioning nowadays companies trying to do a global node. So that's even longer. Like if you are doing a node in Australia and a node in US, the latency is about 1 second. It's pretty long when you think about network systems. So so after all this attempt, I failed to define the scalability is really difficult. But what we are trying to solve in a different system, different projects, are some of the issues, right? It's replicated computation, storage, and overhead. Even though the attempt is failed, but these are some of the issues you always face in terms of challenges. So every node processes all the transactions, they store all the data, and plus we have to total all the ordering of the transactions. That's a must for the blockchain system, for any blockchain systems. So that's where when you do that, so basically these are some of the things across the different nodes you have to do. Like you have to verify and execute the node to achieve the consensus. And there's a ledger to be the fundamental of the consensus to agree upon. And all the ordering, you have to make sure the ordering, the transactions are the data sending to each node to be recorded for the previous majority of the blockchains. And another thing is like every node, they process actually all the transactions, and they should store all the data, and also with more efficient consensus. And that's how the current blockchain focus. But there's companies that are trying to scale the blockchain with only partial transactions, partial data. By doing that, they can scale in a way. But when you do that, how can you make sure the state across all the nodes has the data validated and make sure the data is available, which means you can't doing a transaction transfer one ETH from A to B, but the other node that haven't really recorded that transaction. That will be a big issue, right? That's a double spend issue. And also a Byzantine, there's always systems may crash down, right? Then how do you make sure those systems crash down and come back again, have the duplicated data? So that's what I want to tell you, some of the challenges in the industry. People are trying to define the scalability issues, but in terms of the challenges and problems, it's always there. So people are trying to use different solutions to solve that. But when you do that, there's always sacrifice. Which comes to this section on the trilemma, which is before I talk about the blockchain trilemma, I want to ask you guys, do you still remember these typical CAP problems for centralized systems? And what does this chart trying to say is like for scalable database, if you want to scale, you can't achieve consistency and availability at the same time. You have to sacrifice one to achieve another one. For example, MongoDB is a typical database trying to scale the no-structure database, where they have to choose consistency, partition, tolerance as the one combined to sacrifice availability. So deeper definition for the CEP is consistency. The consistency is like every read receive the most recent write or an error. Because if you don't have this consistency, imagine you have one database receive a writing amount of US dollars for one account, but it doesn't appear on another node. How can you, for example, as a bank service, make sure the balance is correct for the customer, right? And the availability means, so every request receive a response, there is no error. Because imagine if the data you store is crashed on that database, on that partition. You want to retrieve the data from that partition. The data is not available, right? The direct impact for the customer is like, I can't check my bank account balance at all, right? So then there's a partition tolerance, which means you have the system continue to operate even though there's an arbitrary number of messaging being dropped. Why is dropped? Because when you scale a database, if I remember correctly, one single MySQL node can only handle about 5,000 transactions per second. And the data, if you store more than 1 terabyte data, you have to do a sharding for the database, right? That's why you have multiple partition for the data, right? When you transfer data between the different shards, how can you make sure the data is available and consistent? So that's basically what is the CAP theory trying to see. And there are also multiple attempts trying to solve this issue, like all these three issues in one database, but so far there's no database can solve this issue. So why I talk about this? Because I know a lot of you has a computer science background. You are familiar with centralized systems. But when it comes to decentralized systems, this chart become like this, where the scalability, decentralizations, and security become the trilemma, and no single blockchain can solve this issue in one go. Yeah, so this is a typical trilemma issue. A lot of practitioners are trying to describe and trying to solve. So I think the most popular one is Vitalik Buterin was proposing this, like for Ethereum, there's such kind of trilemma we can't resolve. So as you can see on this chart, there are few blockchains are there, like Bitcoin, right? So when you talk about the Bitcoin, the definitely sacrifice the scalability, right? It's only like 7 transactions per second in order to achieve decentralization and security. Similarly to Ethereum, even though they has been trying very hard to achieve the scalability on Ethereum, but I think so far the conclusion is they won't solve the scalability at the Ethereum layer, just because they can't really sacrifice both security and the decentralizations. And that's actually one of the reasons a lot of people believe Bitcoin, Ethereum can survive for a long run. and the value will keep increasing, right? Like Solana and BN chain is a different piece, where Solana declare they solve this issue in one go, but later I'll talk about why they really haven't solved it, and the sacrifice for that is actually decentralizations. BN chain is easier to understand. Basically, they take the same Ethereum fork and using the super machines to boost the performance. They don't care too much about decentralizations because their customer are more like they're centralized exchange customers. The decentralization is not a big thing for them. That's where they can really have a good performance for that. So there, on the other hand, there's companies in order to achieve both scalability and decentralizations, they sacrifice the security. So when they do that, they will have quite a few attacks to their systems. So later on, I'm going to show you typical examples on why that's the case and how the hackers take advantage of that to hack the systems. Yeah, so in terms of the definitions for each of that, right, I still want to define that so that you are clear on what does that mean. So the decentralization means the process of distributing control and decision making from a centralized entity into a distributed network. So what does that mean is like, just now I mentioned when you use a supercomputer to be the node providers, only the ones can afford the supercomputers can be the node providers. That definitely is not decentralized because the vision or the reality for the Ethereum network initially, and Bitcoin initially is every single machine, even a laptop, can run a node service. That guarantees the fully decentralized service network for both of that blockchain. And the security means so measure the protocols in place to prevent unauthorized access and attack on the network. So I think you guys already know if you take 51% of the node, you are able to attack the network. So the security is definitely trying to avoid that. So the scalability is meaning like the ability of the blockchains to handle the growth in terms of the transaction size and usage without losing performance. Again, this is not a common definition at all. This is more like a definition for this trilemma. So when we talk about this trilemma, because we already have the decentralization and security concept aside, then we can talk about purely on the scalability part in terms of the transaction speed and the size of the block and also the usage for the network. So the benefit for the decentralizations is it will be a very trustless systems. It will be fault tolerant because all the nodes will have the data. Even one node is down or multiple nodes is down, we still have the data in place. And also because around that tolerance, you have the communication to make sure when the node crashed, come back, you're still able to bring the data back to the node. That become the communication protocols to guarantee that decentralizations. But there's challenges too, right? As I mentioned, the mining pool, like even just talk about the Ethereum network itself has been aggregated to a few big mining pools because they have the power and the resources to buy those expensive machines. So in Singapore, there's a guy living here, used to call fish pool. So I think at the peak hour, he takes about 20% of all the mining nodes for Ethereum network. So that's definitely not what Vitalik not what he wants to see, right, for decentralizations. The security, when we dive deep, is there are multiple cryptographic techniques Professor Guo already mentioned in the previous class to guarantee the security, no matter the hash, no matter the Merkle tree and all those other ones, to make sure the security is in place. No one can hack that. Then the consensus mechanism, I know you have studied a little bit already, but in the second last of this module, I will talk about some of the consensus algorithms are trying to enhance the scalability, but the core initial purpose of the consensus mechanism are really just to make sure the security is in place. But there's a threat, right? As I mentioned, 51% attack. And there's another issue for double spending for this kind of network. I think only until Bitcoin was born, the double spending was resolved. But because there are more technology are trying to scale the blockchain, there are still network has double spending issues even nowadays. And also there's a network attack. The network attack doesn't mean like for Ethereum you can really take 51% of the attacks because it's so expensive to do that. It's not economic, doesn't make sense economically to do that at all. But the network attack means for some of the scalability issues, the few people have, for example, the professor introduced you the MPC, right? So only few people have the key for the MPC. They can either doing an internal hack or external hack to take advantage of the network. For example, by utilizing some techniques, they can hijack the network to get the keys. Then the system will be hacked. So there's also scalability. When we dive deep, there's some limitations on the block size, on the block interval, and the throughput for the transactions. As I mentioned, for the Ethereum network itself, if you sacrifice the scalability, the big issue is the transaction cost. It's so expensive. I think during a certain period of time, a lot of people, when they're doing applications, they are trying to move away from Ethereum, choose network, for example, or BN chain or Polygon POS. They basically give you very less gas cost to do the applications. Then when you do the real-time application, real-life applications, the network like Ethereum kind of sucks in terms of speed. I'm not sure whether you guys notice or not. There's in Singapore, there's a company or organization is trying to bring the graduation certificate to Ethereum. You still can find it, right? It's basically called Trust Cert or something. So you can search about it. So initially they were using Ethereum, but they give up in the middle just because it's just so expensive to verify your graduate certificate. It's not a good experience either, right? So I think if I remember correctly, they switched to Polygon POS about a few years back. So at that time, the Polygon POS maybe was the best choice at that time. So in this industry, this is a big issue for Trilemma. So on this table, if we add all this valuation for all this protocol, the company behind the protocols, add their valuation together, it's about $1 trillion valuation. That's how expensive it is to resolve these trilemma issues. In this class, we will touch about these few things: the state channel, the plasma, sovereignty rollup maybe, and the smart contract rollup. And basically, these are the rollups we will talk about in more details. So I want to highlight some of the things here, which, if we have time, we'll talk about this. There are companies trying to use the other open source technologies like Cosmos SDK and Polkadot substrate to build the specific application chains. So for this course, we'll try to talk about that. But these are some of the techniques currently in the industry you can use to build that. Polygon Rooney is a sidechain. We'll also talk about that. So later on, I'll have actually a detailed example to show you what's the issues for these two and what happened in the middle. They're also like monolithic chains. It's basically not so decentralized blockchains on this chart. These are the few, even though some of them are still popular, but a lot of industry players define them as monolithic chains, just because they are really not decentralized at all. So I think I'm going very fast. Any questions so far on this chart? Or you have any questions so far on your previous projects and courses, even the things you are working on as a side project? So we won't, I want to highlight, we won't be able to cover all these protocols at all. We were only on the theory piece to cover some of the theories behind, or like in the white papers, how they implementing those few technologies. Like we don't have time to go through Aptos, SUI, and all those protocols at all. But if you are interested, you can always open their white paper and read about it. We won't go through the details of each of the state channels, for example, the Raiden and Connex and Sala. These are all die already, but they leave us a legacy for some of the specific applications. You can still use certain techniques to do scaling for blockchains. Yep. Any question? No? So before I'm going through the specific examples, I want to give you maybe another overview on why the scalability is like that on this chart itself. So the first one is easy to understand. I already go through, like Solana, for example, they use powerful machines to boost the performance. So that's how they are doing this. More expensive hardwares. The sidechain is basically a place is easy to understand in a way like rather than having all the traffic on one blockchain, for example, Ethereum, if I'm the ones building this blockchain or using the blockchain, why can't I move the traffic to another chain? Imagine it's in parallel, there's Ethereum 1 and Ethereum 2. Ethereum is very congested. Why can't I move the transaction to Ethereum 2? That's the logic behind for the sidechain. The application-specific chain is in a way like I'm the one doing the applications, and I have the full control. Maybe my users don't care too much about the decentralizations or some piece of the security, because I control the MPC wallet, for example. Then I can build this Cosmos, right? Using the Cosmos to build my own application chain on layer 1. So another, this part of the reasons behind is the companies feel like Ethereum has been dominant already, and in order to scale the Ethereum, I should have another way to scale. It's not only for Ethereum, but also for Bitcoin, for example. So that's where they introduce the state channel and Plasma, even all the roll-ups, right? The roll-up, basically it means I burn all the transactions on top of Ethereum, where we do all the computation, even the storage on the off-chain. The settlement, which means all the Merkle root will be calculated, and the settlement will be calculated on the Ethereum as a part of the smart contract, to make sure I derive the security from Ethereum, but I offload those computation and storage onto rollups or off-chains so that I can scale Ethereum. So that's the logic behind all the rollups. Yep. So I'll give you this example. This is a very typical example in the industry. People always talk about Axie Infinity has been a very popular games in Southeast Asia, grew out of Vietnam. The game is like this. It's a very simple RPG game. A lot of Filipino playing the game. We're playing the games to basically earn the tokens. Then they sell as an income. At the peak time, it's very ridiculous. Those people are just living their lives by just playing this game. So Roni is a very typical sidechain. The Axie Infinity was developing because the game was so popular, and there are so many people playing the games. So basically, they launched their tokens on Ethereum, but they decided to bridge all the tokens to Roni sidechain, so that all the transaction only happening within Roni sidechain if you only play the game during the transaction in the game. So they have implemented different token for the purpose of the games. But there's a hack, I think about 2 or 3 years ago, where in this sidechain, I won't go into the details because later on we will go into the detail of the sidechains. But the hacker is trying to make use of the security issues for the sidechain, where any sidechain, if you want to sign the transaction correctly, you have to go through this validator check. So the hackers was able to manipulate the validators, and basically they take the private key of the validators and take the ownership of the validators, and they did a withdrawal transaction from the network. Because of that fault transaction happening on the network, Roni or Axie Infinity lose about I think 16 billion USDC on the assets. It's a big loss. But to the hacker, they took a lot of energy and resources to hack the system. They kind of hack away all this money from the Axie Infinity. Yeah, any question to this one just now? I'm not sure you guys played this game before or not. Hopefully, by introducing you the game, you understand a little bit how they build this sidechain, and when they were facing the trilemma issue,
They sacrifice the security, and they not only sacrifice the security issue, but also sacrifice the decentralizations to boost the player experience. They just had no choice at that time. So that's how actually they got hacked. And that's why the trilemma issue is so important in the industry they are trying to solve. So you may imagine, right, if we were doing a application, we don't need to struggle that much. Why we have to really highlight the trilemma? It's all because if the trilemma is not an issue, we can just use Visa, MasterCard, and to solve all the issues. But that's not the purpose for blockchain. So I think I have been in the industry for 2 years. Before that, I was advising a project in 2018. The sad truth is, in the industry, it's a little bit pessimistic, but the reality is like 99% of the projects doesn't make sense. Only 1% of the projects, so that the companies has been really trying hard to fulfill the initial goal of the blockchain, which is computational integrity. It means a lot for the pioneers initially proposed this idea on the blockchain. The idea is, without anyone watching the system is integrated. That's why we have this blockchain. That's why the trilemma is so big issue, because everyone is trying to achieve that if they take a trilemma seriously. If not, right, yeah, so then this is not an issue for them. As I mentioned, right, in the past, to achieve the computational integrity, people choose to trust the central authority, like the banks, like the government, where they are the authority. And they provide the service. By right, you can really ignore the decentralization. That's where they use all these big computers. I mean, I used to do that too, right? So when I was working for PingCAP, so about 60% of the internet companies in China, companies like there's the largest e-commerce company in Flipkart in India, also using that database. Shopee also using that. They use super powerful computer to handle the workload, to handle millions of transactions on the busy shopping day. It's because we trust we trust them, right? Like Shopee, we trust Shopee, they can handle our transaction honestly. That's where they kind of authorized to use the big computer to handle the big workload. But for the blockchain, the blockchain believe that's not the best solution. We shouldn't trust anyone. Everything needs to be verified, and the computation need to be integrated. That's why the decentralized network is proposed. And that's why I mentioned even a single computer, a laptop, should be able to run the blockchain to achieve that. But it is not an easy thing to do, because if we only stay in a small cycle, that's fine. But if you want to go beyond to a mass adoption, it's not easy at all. Yeah, so that's the current situation, right? But there are, again, I mentioned there are companies like Solana, they are trying to increase the scale for blockchain. For the centralized service, easy. If you want to handle, if you as a startup, you don't have so much workload, you just need to adding database can be doing multiple shard to increase the throughput, the computation, to increase the storage and the retrieval. You can use the load balancer to increase the scalability for the workload when the user is trying to retrieve the data from the data storage. So for the database, for the blockchain, same thing. So like Solana, they use super powerful computers to increase the performance for each node. The issue is these small players, like personally, you can't contribute your node to the network at all. So that become more centralized. That's definitely not what the blockchain initially for. So look at the computers, the chipset the Solana need in order to run Solana network. So these are the CPUs they need. So that's what I mean as a common users, we can't afford to run this kind of node to be the part of the blockchain. And another issue is like when they have this kind of hardware, on one hand you have to trust them, the node operators. On the other hand, you need to trust because they don't have a big audience to have the consensus, to have the algorithms running in decentralized way. You have to trust the guys running, operating, or writing the source code is trustable. And that's a key difference between Solana, for example, and Ethereum or Bitcoin. If you observe the Ethereum and Bitcoin community, it's fully open source. Everyone can propose their own proposal as a EIP or BIP, and it's very open. But for Solana, it's decided by the team itself. I'm not trying to say like Solana is bad, just tell you a truth. When you make the things more centralized, everything is actually coming back to the centralized service relatively. Other than that trilemma proposed by Vitalik, there's actually another trilemma, which is while you scale the blockchain, do you scale on the performance, or you want the composability? The composability means you are able to write smart contract, deploy smart contract onto the network. Some of the scaling solutions, they are not able to deploy smart contract if you didn't realize. Then decentralized is the same. This is not changed. So some of the example, you may not understand, well, like what does this sacrifice composability mean? Some of the examples is here, like DYDX, Diversify, and Sorare. Some of the examples where they were using Stackware technologies, it's called StarEX, to scale on the asset tokenizations, where, for example, the DYDX is more like a perpetual DEX. So when you do the perpetual DEX trading, underneath for DYDX, at least before version 4 for DYDX, they are not able to deploy or change anything underneath. It's all fixed. So we'll talk about that one later too, how, for example, Stackware achieved that without able to deploying the smart contract on the network, but achieve the performance and decentralization at the same time. So the others may be easier to understand, like all the applications here, like Uniswap, they are not that centralized. The reason we call it they are not decentralized is because the protocol itself is running by the team. even though underneath they are deploying onto the decentralized network. So this trilemma is more from the application perspective, not from the blockchain perspective. Yeah. So then, this one may be easier to understand. Like all these, you realize there are two versions of the Uniswap here. It's because in the middle, Uniswap deployed to network like I think they deployed to Optimism already, where they sacrifice the decentralization for the application. But for the version 1, they deployed to the Ethereum, where the performance was not really good. Yeah. So this is not another trilemma, thinking from the application perspective. Yeah. So this is a very typical architecture for a centralized exchange. I'm not sure who of you has working for a centralized exchange before. Anyone? No? Do I need to go through this one? Like how, at the time of Ethereum being popular, ICO time, how the centralized exchange scale the trading of tokens. Any of you want to go through this one, or I go through this? Yeah. So basically, in the early days, for like Binance, Huobi, they were actually my customer in the early days. How they doing this are like the users, they deposit their token into the centralized exchange wallet. And once you deposit the token into their wallet, the token belongs to the centralized exchange, not you anymore. Sounds familiar? So this basically is very similar to the banks. You deposit money to the banks and you trust the bank take care of all your assets, right? But after that, right, so they create your assets in their database here. And once you have that, for example, you have USDT in Binance, then you are able to trade on the token pair. But what you are trading is not on blockchain at all. It's on their database. So when you basically they fetch all your assets from the database to their UI and show you, oh, I have this amount of assets, I can buy tokens from different places to exchange or swap to other tokens. So so again, right, all these wallets are managed by the centralized exchange. The few people in the company have the keys that they are able to unlock the wallet to do certain things. Can be bad things like FTX. And this become very insecure, to be honest, if things like FTX happening. Well, at that time, I think a lot of companies really don't have so many choices. Because even nowadays, well, the good thing is like they can make all the user experience very good. Because as a common, for example, users, you don't use crypto too much. The centralized exchange provided you a good experience. You can log in with your email or Facebook. But on the other hand, the asset is really not secure. So if you ask me when this can be changed, I don't know. Like even nowadays, the most crazy market, for example, Korea, if I remember the number correctly, 95% of the users are still using centralized exchange to do tradings of the tokens. Yeah. But with DYDX, for example, everything is changed, at least in a way, even though not fully, because we have to struggle between the user experience, more like how you can log in, when you do the trading, how fast you can close the trading. And when you want to transfer the money, the token from one exchange to another, how can you smoothly transfer? So that's what I mean, the user experience. We have to balance this user experience with the current technology on the scalability piece for the blockchain. So this architecture is from DYDX. So when they do that, about I think 5 years ago, they choose not using Uniswap solution because for Uniswap solution, big issue at that time is running on top of Ethereum at that time. If you are running on Ethereum, like ICO time, you still remember the chart for the hype or the gas, right? You can't trade. Like you buy 100 tokens, maybe cost you only $100, but the gas costs you $50, right? It doesn't make sense. So that's why they choose at that time a good solution. Underneath they use here underneath is actually on Ethereum, where when the users do the trading swap, they come to the UI, the DYDX UI first. So even nowadays, if you come to the DYDX on the version 3, you can still choose. You can underneath is still this architecture. The token will be actually coming to here. We call it a batch, trading batch, where they batch all these transactions together into a one batch. So other than putting all this transaction into Ethereum, which will come back to the same situation for Ethereum, they actually only, we'll go through in detail later in a roll-up session. But in the essence, they aggregate all this state, the transaction state, into a Merkle tree. And they generate a Merkle root. And only this Merkle root state come to the Ethereum, where we call it a proof. If you still remember, Prof. Guo go through the zero knowledge proof, and also, and I think Justin also goes through during a small the semester, goes through the ZK proof too. So using the same ZK prover to generate a proof. So that proof basically are able to prove all for this transaction compared to all the previous transactions. This transaction is integrated, and no one doing the bad things during the transaction happening. And the fourth one is the state will be updated once they generate the proof. And this small contract running on Ethereum will validate the state is integrated and no one is touching around it. So this is the whole flow for the after so many years, the industry are able to achieve a little bit scalability. And even with this, right, I think the DYDX at the peak time, they can only handle 100 transactions per second. It's not as good as a centralized exchange at all. So that's where we are on the scalability front. So imagine from here to the centralized exchange experience, it's a big gap. The big gap is actually, on one hand, it's a challenge. On the other hand, it's a big opportunity for all of you once you join this industry. Yeah. So with that, right, I finished this session very early just because I want to give you time to ask me questions on the projects. But feel free to ask me any questions. We may pause about 5 minutes time. You can ask me any questions if you have on this session. I won't go to the details of the theory and protocols at this lesson. I just want to give you guys a little bit buffer before we dive into the protocols on how all the scalability has been achieved. Any questions so far? Yeah. Mm. Yeah, yeah. This is done by DYDX. The UI is definitely coming from the backend, centralized backend. The whole trading, the assets, all on blockchain. It's not on their centralized database at all. The order book, you are right. The order book is actually on the centralized service. Yeah. So the benefit for this one is compared to the centralized exchange is the user own the assets. The asset on chain. This is more like an asset tokenization. This is not like everything on chain. Yes, yes, because the order book, the workload is pretty heavy because you have to map all the pairs, right? And the mapping itself, when like hundreds of thousand people trading together, it's a lot of work. Blockchain so far cannot handle that. So the way currently the blockchain are trying to resolve are using AMM to make sure the slippage is as little as possible so that the users won't complain. But this is more like a trade-off other than a good solution. Asset on chain. Like, so basically for the DYDX, if you guys test that out, you can use USDT or USDC to buy certain pair of tokens, increase of the price or decrease of the price, right? It's more like a perpetual trading. So when you do that, so basically they lock your USDC with that token pair. That token pair itself is not on chain. It's on an order book, right? Only when they trade that assets, the USDT and USDC, locked with that pair, that logic is on chain. Yes. So the direct benefit is like any time the user can withdraw money, and no one else can touch the assets on the platform. So that's why when you trade on DYDX, the trading wallet is like MetaMask and all those decentralized wallets other than centralized wallet. Yeah, that's a direct benefit. Yeah. Okay. Yeah. Hmm.
Yeah, I would know the difference between the search engine of sex and search engine of sex. As we know, we often talk about the search engine of sex. It's always matching the transaction between the buyer and the seller.
Yeah.
So I want to know what is the matching engine of sex.
Yeah. So as I mentioned, right, he actually also mentioned the matching engine is very computation not heavy. So even for DYDS, they can't do that. That's why they choose a centralized order book to do the matching. It's very similar to centralized exchange. The difference is like the assets still on chain. But you can go back and study AMM. So the AMM is the more typical kind of order book for decentralized exchange. I was not using that as an example because that AMM currently is fully dependent on the scalability of the blockchain. The AMM is running on top. So there's also open source AMM like Uniswap. They have open source. Uniswap is based on AMM, so you can basically read their source code and how they doing the AMM on top of blockchains. So that one is running on the blockchain, but they are not doing heavily matching. So that's why there's a slippage kind of algorithm to make sure the users spend less cost to get that token bought. Yeah, it's just an algorithm only. It's not like doing heavy matching. It's not like a centralized service. So that's why this basically is called MEV, where there are companies trying to make use of this kind of slippage, where you can insert multiple transactions in the middle to hijack some of the transactions. And then the end users may not be able to get the token in a fair price. That's a big issue, actually, in the industry right now. Yeah. So some centralized exchange, not centralized exchange, some centralized blockchain. The owner of the blockchain are also trying to make use of that to get money from that. So that's what I heard. Yeah. Any other question? Yeah, go ahead. This one? Yeah. Which one? Yeah. Oh, again, I'm not talking about a generic ZK-ROP here. The ZK-ROP is more like the chart is a little bit wrong. It's actually talking more about this part of the applications. These are the pioneers of the companies using the ZK-ROP, where in the early days, the ZK-ROP only support ERC20, ERC721 doing the asset roll-up. So I will go through this part in details on how they do that. So actually very similar to here, to DYDX. DYDX here is also using the ZK-ROP, the first version of the ZK-ROP. It's called StackEX. zkSync also did that before, but they kind of failed. But for this one, as you can see, they can only support the customer doing the USDT, USDC token trading. For DYDX, if they want to deploy AMM, they can't, because the things running underneath are stuck where we call it the Stack Exchange, StackEX. That's the first generation of the ZK-ROP. Yeah, so the chart means that, other than the current ZK-ROP. Yeah, sorry for the confusion.
So the category is based on application perspective?
Yes. Well, the current facts is for the optimistic roll-up category, we currently can run roughly about 1,000 transactions per second. So that's how much workload you can run. That means you can't run an order book. You can only run AMM for DYDX type of application. If you want to implement the whole logic of DYDX on a generic roll-up, especially ZK-ROP, because all the assets are very expensive. It's not like a generic application where the assets not that precious. So if you want to do a DYDX type of application on top of ZK-ROP, the ZK-ROP will hope you don't have too many users, because the maximum throughput for the ZK-ROP The best one so far is Stocknet. They can only handle 100 transactions per second. The ZK Sync is about 50 transactions per second, and Polygon is about 20. Scroll is about less than 10. So that's where we are on the ZK ROP front. That's the latest data we have. Yeah. So I will change this part, not a ZK ROP, but more like a application ROP. Yeah. Well, that's the direction, right? So everyone is trying to achieve that. So the reason they currently have this limitation are, in general, ZK EVM and ZK VM are two different directions. We won't go through that part in this lecture at all because it's too details. But in general, when you run a ZK EVM, you will basically transcode the OP code, which is the Ethereum, to a circuit. So when you do that, they sacrifice the performance a lot. Compared to the ZK VM, why they are not EVM compatible is because when they choose ZK VM, it means they design the programming language based on the circuit logic. It's like you have a different Web2 language for different purpose, right? Similarly to the ZK ROP landscape, they have a different trade-off. The ZK VM choose to performance. Even the performance is the best performance so far is only 100 transactions per second. There are a few limitations so far, like Starnet Carol VM is actually the current limitation because the VM is only like a first or second generation for now. If you dive deep into the GETH, GETH, Ethereum client, if you only run that VM, it can handle about 10,000 transactions per second, the VM itself, right? So from that, it took many generations for the Ethereum VM to be like that. Similarly to all the ZK VM, they will take time to improve. Yeah. So another bottleneck is the ZK proof, the efficiency. That efficiency to me is not that big issue so far in the industry because that's more like a finality. Yeah, proving time. The proving time is currently about a few seconds. But in general, the way the ZK ROP is doing is they give you a soft confirmation first. That soft confirmation is only like 100 milliseconds. It's not like a few seconds, right? So from the user experience perspective, it's okay. The finality, the proof, time still take time. These kind of ZK ROP companies are trying to enhance that. Even the way of enhancing, different companies are choosing different directions. Stackware choose to use algorithm to improve. ZK Sync, Scroll are choosing to use GPU to accelerate that, which means they will never be decentralized for the ZK VM, but for the ZK EVM. But for ZK VM, there's still a chance. Yeah, the issue is not you fake the ZK proof. The issue is here. Huh? That's one thing, right? The other thing is like why even ZK VM, ZK ROP solution needed decentralized is because it still comes back to the transaction sequence. So when you're doing all the sequencer, even though this is not for general ZK ROP, you imagine This is a generic ZK wrap. So all the transactions will come. Who decide who will be the first one to be in the sequencing, in the batch? That is actually very important when you do trading, right? So that's why currently all the ZK wrap are centralized sequencer. Companies are trying to do decentralized sequencer, like Reddio. But even the prover is the same thing, because if you, as a centralized service, it's actually happening now. So if you decided to not prove this whole batch, you can just tell the sequencer, sorry, this batch is failed on the prover side. And you have to roll back for the whole batch, which again, right, very centralized. Imagine the government, US government trying to tell you like, oh, sorry, there's a transaction in this batch is not valid. I want you to take it down. For a centralized prover, you can do that. That's why even the prover should be decentralized from the computational integrity perspective. Yeah. It's a good question, though. I didn't imagine we touched that part in this class. Any other question? No? All good? Cool. Yeah, I wanted this session to be more interactive because this session will really help you why the industry has been trying so hard to scale and secure and also decentralized. It's not an easy task, but it really means a lot to a lot of different players in the industry. Yeah. Cool. With that, we can close this session. Thank you so much for attending this class. Hopefully it's useful. And do come to me give me more feedback. For example, if you don't want the last class to talk about how to build a blockchain, you want to touch on other parts, I'm flexible to change that still. Yeah. Thank you so much, everyone.